In this video, we'll be looking at a compound interest problem. To solve compound interest problems, we need to use the formula A equals P times the quantity 1 plus R divided by N, and then that quantity raised to the T times N power. The A in this formula is called the future value, and it is the amount in the account after T years. The P is called present value, or sometimes principal, and that is the amount that's being deposited. The R is the annual interest rate, written as a decimal. N is the number of times that the interest is compounded per year, and T is the time in years. The problem that we'll be working with is, suppose you have to pay a lump sum of $15,000 in 8 years. The question is, what amount deposited today at 4.8% compounded annually will give you $15,000 in 8 years? So let me write my variables that I'll be working with: A, P, R, N, and T. This is a future value because we're going to be paying that amount in 8 years. So this is the A value. And our time is 8. What amount deposited today? So that means we're looking for the present value. The percent, this is our rate. We need to write it as a decimal. Remember that you take this decimal point and move it 2 places to the left. So 1 place would put it in front of the 4, and we'll need to annex a 0 then to move it 2 places. So 4.8% will become 0.048. The interest is compounded annually, which means once a year. So N is 1. So our problem then is 15,000 equals P times the quantity 1 plus 0.048 divided by 1, and then that is raised to the 8 times 1, just using this formula. These ones here make for easy arithmetic. Let's go ahead and write it without those. I still need that one, but 0.048 divided by 1 is just 0.048. And then that's raised to the 8th power. Since I'm solving for P, I'm going to need to divide both sides. And I'm going to go ahead and write that right now, because I would like to do this math totally on the calculator in one step. So let's just divide by 1 plus 0.048 raised to the 8th power, and this side as well. 1 plus 0.048 raised to the 8th power. So this factor will cancel with that one, and I'll have just P on the right side. And then I need to do this math, 15,000 divided by the quantity 1 plus 0.048 raised to the 8th power. So 15,000 divided by, and then I'm going to open my parentheses, do that math, 1 plus 0.048, and of course you could do that in your head. I mean, adding this decimal to the integer 1 is just going to be 1.048, but I wanted to show you how we could do all of this right on the calculator. So I'll close my parentheses, and then when I raise to a power, the exponent only acts on what it's directly next to. So since my exponent, my power button, this little caret, is directly next to the parentheses, that means that this group right inside the parentheses here will be raised to whatever power I tell it to raise it to. And so I'm going to raise it to the 8th. And we have 10,000 $308.63. This 1 isn't big enough to make the 63 cents go up to 64. So this is my amount that I need to deposit now so that I will have the $15,000 in 8 years. Now let's look at how we would do this problem with this calculator. On this calculator, I need to do everything backwards. So inside the parentheses here, I have 1 plus 0.048. So get a number there. And then I need to raise that to the 8th power. So raise that to the 8th power. And I have 1.455. Now I'm not going to round that. I'm not going to take just a piece of that decimal because I want my answer to be as accurate as possible. Now what I would like to do is take this number and do something with it, with this 15,000. Notice that this number was in my denominator. Okay? But in the calculator now, this is not in the denominator. So in order to write this in the denominator for this calculator, I can press my 1 over x button, which will put it 1 over this number, which is what it actually is, and then I could multiply that by 15,000. So let me do that first, and then I'll show you another way in case you can't remember that one. So if I hit the 1 over x button, that will turn that into the reciprocal, and then multiply by 15,000. So I get the number, and I didn't have to round my number that was in the calculator to begin with. So a little note in case you have this type of calculator. So 1 over x and then times 15,000. That's one way to do this. Let me write denominator. Period. So that's denominator. Hit 1 over x and then times 15,000. So another way that we could do this is 1 plus 0.048, hit equals, raise that to the 8th power, and then this number we could store into a memory. Now on this calculator we have 3 memories. So to store this in a memory, we would hit the store button that's right here, and so hit store, and then it doesn't look like anything happened, but what you want to do is either press 1, 2, or 3. If we want to store it in memory 1, hit the 1, and you'll see now that that number should be in memory 1. So if I clear everything out, this is still showing here. So I can get that back by recall 1, and there it is. Okay, so store 1, or if you want to store 2, if you've already got something in memory 1, you can hit store 2 or store 3. Alright, now we have the denominator stored in memory 1, and so we can take 15,000 divided by, and then we'll recall 1, and that brings that number back, and then hit equal. That's another way to do that. So another way then, make a note, we can do the denominator, and then store 1, and then 15,000 divided by recall 1. So those are the steps or the buttons that you need to push to do this. This is one way to do it, and this is another way. Alright, let's continue with this problem. I want to keep this formula visible. So we're going to continue with the problem. If only $10,000 is available to deposit now, what annual interest rate is necessary for the money to increase to $15,000 in 8 years? Right, again, I'm going to just write my letters or my variables that I have to work with. A, P, R, N, and T. $10,000 is available now. So remember that that's your present value. Whatever you have available now is your present value. That's what you're going to be able to deposit. So my P is $10,000. What annual interest rate? So I need R. I don't know what that is, so that's my question mark, basically. What annual interest rate is necessary for the money to increase to $15,000? So at the end of 8 years, I need to be able to draw out 15,000. And remember that from our original problem, the n was 1 because it was compounded annually. Right, I'm going to let me write my formula here so I can scoot my paper up. So my A is 15,000. My P is 10,000. I have 1 plus R is the variable that I don't know. N is 1. My T is 8. And my N is 1. Alright, now this time my variable is inside here. So let me simplify it and get rid of those 1s again. We have 15,000 equals 10,000. times 1 plus r raised to the 8th power. All right, now this is sort of like a Christmas present. We have to unwrap it, so we have to take layers off. We have to peel off things so that eventually we'll get in there and find out what R is. So the first thing that I need to take off of this right side is this 10,000. Since the 10,000 is multiplied by this quantity, I need to get rid of it by the inverse operation, which is division. So I'm going to divide both sides by 10,000. These will cancel, and I'll have 1 plus r raised to the 8th power. And then on this side, I have 15 over 10, which is 3 over 2. Or if you prefer, this is a nice decimal, 1.5 is fine. All right. The next thing that I need to peel away is this exponent. Remember that to get rid of an exponent, we can raise both sides to the reciprocal power. So I'm going to do that. You can do reciprocal power, or you can do the 8th root. The reciprocal of 8 is 1 over 8. So I can raise both sides to the 1 over 8. So this then, 3 halves raised to the 1 over 8. And then on this side, these cancel, and I have 1 plus r. On my calculator, I have open parentheses, 3 halves. I'm going to use my fraction key. And that, I need the parentheses around that, or else the exponent will only act on what it's next to, which I want it to be the whole fraction. And then I'm going to raise that to the fraction 1/8. And it looks like we have 1.05 19895. I'm writing so many because I have a 0 back here at this point, so that's a good stopping point. Plus, I want to change to my decimal before I truncate or round. Now that expression is 1 plus r. So subtracting 1, that'll be the last thing we need to do to isolate our r. So we have 0.0519895. Now since we want that to be a percent, let's move our decimal 2 places to the right. So it looks like 5 point. And let's go ahead and keep 2 decimals on this percent. So 5 point, the 19 will round up to 20. This is my rate. Now let's see if we can do this on this other calculator. We got to this point without a calculator, but let's go ahead and take our 3 halves. That's the fraction 3 halves. And then hit y to the x. And then I want to raise that to the 1/8 power, so I got to use my parentheses. 1 fraction 8. Close the parentheses and hit equals. So that gets me to this.